In today's video, we're going to take another look at some area and volume formulas, but this time we're going to look at either solving for missing information or what's going to happen to those areas and volumes when we change one of the values that we plug in. So let's just look at a few examples of each, and then absolutely, let me know if you have continuing questions on these or if you need some extra help on any of the materials that we're working on so far this unit. So our first example, we are given a rectangular prism. It has a base area of 300 meters squared and a volume of 6,000 meters cubed. If the height is 20 meters and the length of one side of the base is 10 meters, what's the other side of the rectangular base? Now there's a few different ways that we could approach this, but the first thing I'm going to suggest is let's label the information that they gave us about the shape and figure out what we're trying to figure out. So the height of this figure is 20 meters. So again, the height of any prism is you're always looking at what's the distance between the two bases. So usually up and down, but sometimes I might draw it separately or kind of drawn sitting on its side just so you can see better what's going on. It really doesn't matter how we approach it with this problem with a rectangular prism. So I'm just going to count that edge as my height. And so we know that height, they gave it to us as 20 meters. Okay, and actually, let's move that over to one of the back edges just so we don't have overlapping labels on here. So here's what we're going to set as our height is 20 meters. Okay, then it says the length of one side of the base is 10 meters. So let's go for the shorter one. And again, keep in mind, this diagram may not be drawn to scale. This is just a generic rectangular prism that I grabbed a picture of. So let's say that that length base is 10 meters. So that's one length. So let's look at the info they gave us. So we could either look at base area is 300. Well, wait a second. Our base, or the bottom of our figure, and let me change my color on this. So let's look at red. So if we're looking at the base here, they're telling us the area of that base is 300, and what they gave us 10 as one of the lengths. So we could use that to solve. Or let's see, they gave us the volume as well. In any case, they're asking us to solve for what's the other side of the rectangular base. So we're looking for this length right here. So wait a second, if I go back and I look at my formulas that they give me for this kind of figure, the very first one that I see is volume equals LWH. So in other words, length, width, and height. And with the way that we have things labeled, I would absolutely consider that green length that we're looking for, we could call that the width. So let's see here. Volume, well, they gave us a volume. Let's plug that in. So 6,000 meters cubed. And they gave us a length. They gave us the 10 meters. So 10 meters. We don't know what the width is, so let's call that W. And they gave us the height of the overall figure. They called that 20 meters. So once I plug everything in, actually, I'm only missing one variable, and we can just use algebra to solve. So the first thing that I'm going to do is, for the moment, I'm going to go ahead and ignore my units. We're still going to put them in at the end of the problem. But let's go ahead and just deal with our numbers so we don't have any extra letters in here. And I can go ahead and combine things on the right-hand side, because if I'm just multiplying everything, I can multiply the 10 and the 20 together. So that would give me 200 W. So now all I need to do to solve for W is divide both sides by 200. Alrighty, so 6,000 divided by 200 gives me, I believe, 30. So W equals 30. And because we are looking at all the same units on here, our length was in meters, our height was in meters. To get up to meters cubed for volume, that means our width also needs to be meters. And let's just double check, make sure that info works out. So volume should be length, 10, times width, which we figured out was 30, times height, which is 20. And if we multiply all those together, well, 2 times 3 gives me 6, and we have the 3 zeros all multiplying in. So we have 10 times 30 times 20, which gives us 6,000 with those 3 zeros. So everything checks out with what we figured out. All right, so again, I picked out what information they gave me, I labeled what I could, and then I picked out a formula that would let me solve. And again, we could have done this with just the base area. So base area is 300. If I divided out the 10 that they gave me, that would also leave me with 30 as my leftover. But looking at the formula that we have, surface area for this kind of figure was 2LW time, or plus 2LH plus 2WH, definitely a lot more complicated to solve that for. So volume was probably the good way to go. And again, those volumes, I'm grabbing them right off of the formula sheet, so I don't have these necessarily all memorized. So absolutely have that out as you're working on your practices, or even as you're working on this. You can either copy them down on a separate piece of paper, or you could always print it out if you have access to a printer. But again, you're allowed to have that tab open while you're working on your quiz on this next week or any practices. Okay, next problem. Example 2, the volume of a cone is 100 pi inches cubed. If the radius of the base is 5 inches, what are the height and the slant height of the cone? So again, let's label what we have. We have our cone. We know the volume is 100 pi inches cubed. So the first thing I know is volume. I've got a formula for that. Let's write that down. So volume equals 1/3 pi r squared h, right off the formula sheet. Okay. We know the radius of the base is 5 inches. So radius, again, always goes from the center out. So we have 5 inches. So what are the height and the slant height of the cone? Well, first, let's plug in what we know and figure out what we can solve for. They told us the volume was 100 pi. So let's plug that in. So 100 pi. And again, I'm not worried about the units as much at this stage, but we will definitely want to put those in at the end of the problem. Okay, then filling in the rest of the formula, we've got 1/3 pi. And again, pi is just your constant, approximately 3.14159. You've got the button that you can use on your calculator or on the Desmos calculator as well, should have pi. R squared, well, they told us radius. So that's 5 squared. And the only thing left over is the h, so the height. So that's the first thing that we're going to be able to solve for. So let's see, I do have some simplifying that I can do. So I could go ahead and square my 5. So that's going to give me a 25. And then we've got a bunch of stuff going on in this formula. Do you see anything in common on the left and the right? Huh. Well, both of these have a pi, so let's just divide that out. So rather than dealing with the big long decimal that we might need to use, sorry, going to the correct tool, let's just go ahead and get rid of it. So divide both sides by pi. That will simplify out the pi on both sides. And then we are left with some more approachable algebra. So 100 equals 1/3 times 25 times h. And I don't know about you, but I don't really like having that fraction. How is it that we've dealt with fractions in our other problems before? If I have 1/3, I've got a 3 in the denominator. How can we get rid of it? Well, let's just multiply both sides by 3. So multiply this side by 3 and multiply this side by 3. That will cancel out our denominator for us. And then let's simplify out what we have. I'm running out of room, so I'm going to go up to the next line. See, on the left-hand side, 3 times 100, so 300. And then on the right-hand side, now all I have left is 25 times h. And so divide both sides by 25. And we're there. So let's see here, 300 divided by 25 comes out to a very nice number of 12. Now, if we're looking at the height is 12, just a length, what do you think our units are going to be? Yep, those should just be inches, just like the radius was. So 12 inches is the height. Let's go ahead and label that. So there's my height of 12. Wait a second. Do you see another picture popping out at you on this now? Yeah. So let's go back to the problem, make sure we answered everything. And it says, okay, volume information, radius of the base is 5 inches. What are the height and the slant height? So we still need to figure out slant height. So I'm going to color code that green. So slant height is just what it sounds like, the slanted height. And if you look at your formula sheet, you've actually got something labeling this kind of tilted side on a cone. They call that L. And once I draw that in, what kind of triangle are we dealing with now? What do you see in the diagram? Yeah, I see a right triangle in there. So to solve for the hypotenuse on a right triangle, all we need to do is Pythagorean theorem. So 5 squared plus 12 squared equals L squared. And you might even notice this pattern, but keep going with the math if you don't. So 25 plus 144 equals L squared, except 25 plus 144 gives me 169. And so to get the L by itself, I need to take the square root of both sides, which yields that L equals 169, 13. And same thing like we did before, this is just a length on the diagram. So we do need to add units, so 13 inches. And again, you might notice that number 12 or 5, 12, 13 is one of those Pythagorean triples that we studied back in our right triangle unit. So if you recognize that pattern, you're more than welcome to use it. So now let's look at example 3. So the volume of a triangular prism is 84 meters cubed. If the height of the prism is 7, what's the area of the base or each base? And so, that wording is important. When you have a prism, again, you technically have 2 bases. When you're thinking about the terminology here, it says triangular prism. So the triangle is important. And in fact, you have a triangle on the front and a triangle on the back. Every prism is going to have 2 bases, but this one, they just tilted on its side because it was a little easier to draw it that way. And so that's the piece that we're looking for. When I start reading the volume of a triangular prism, so the first thing I'm going to do is look for my volume formula, which is V equals big B H. If you're looking at your formula sheet, it's on the side with all of the area and volume formulas. It's on the second row, third one over. And so the first volume formula that you see there, again, volume equals big B times H. And the big B, well, that's this red piece that we shaded in front and back. That's what we don't know. If I look back at the problem, it says the volume of a triangular prism is 84. Well, I can fill that in. So let's go ahead and do that. We know the volume is 84 meters cubed. Again, I'm going to go ahead and leave the units off for now. The height of the prism. So really, they're talking about the height or the distance between the bases. That height is 7. So that means we don't know what the big B is. So we'll leave that red. But we do know that our height is 7. So if we're looking for what's the area of each base, as soon as we solve for that big B, again, that's what is the area of the base. So to do that, just divide by 7. So if I divide both sides by 7, that will leave me with, let's see, 84 divided by 7 gives me 12. That's not too bad. Now that is an area. So if our units on this one are meters, then the units for the area of the base should be meters squared. So let me update that. So 12 meters squared. Not too bad. Alrighty, so the last 3 examples that we're going to do today are talking more about if you change something on your figure, what's that going to do to your surface area? What's that going to do to your volume? So it's the same sort of thing. We always want to pick out the appropriate formula first, fill in what we know. Then on this one, we're going to fill in something that'll show us what we're changing. And then we figure out what's going to happen with the algebra from there. So example 4. A triangular prism has a volume of 225 inches cubed and base area of 15 inches squared. So let's start out, actually just go ahead and write our formula. So again, let me make sure I'm on a good color. So volume, same formula as we used last time, equals big B times H. So in this case, big B, again, that's going to be the area of our triangular base. The H, that's the distance between our bases. So big B and H. Okay, volume was 225 inches cubed. Area of the base is 15. So that means we don't know what our height is. But then they tell us to do a modification. So here we go. The height is going to be doubled. So if I take that height and I multiply it by 2, that means I'm going to rewrite the right-hand side of the equation. I have to multiply it by 2. Wait a second. Can I do that in a formula? Or actually, can I do that in any equation? Can I just randomly multiply one side by a 2? Well, no, I can't. Whenever we're solving things out, we always do the same thing to both sides. So we either subtract from both sides or we multiply by both sides. So let's do that. Since I had to multiply the 2 times the h on the right-hand side, let's go ahead and multiply the 225 by 2 on the left. So I'm doing an equal thing on both sides. So let's see here. What's that going to do to the 225? What is going to happen to our volume? So that means just take 225 times 2. 225 times 2 gives me 450, which is double the volume. So we doubled the volume. So again, it's really just looking at what your setup is and algebraically trying to figure out, well, what are they really telling me to do overall to this equation? Alrighty. Number 5. If the height of a right cylinder is multiplied by 4 and the radius remains the same, what happens to the lateral area? So same thing on this one. They're just telling us to do one thing to one measurement, and then we have to figure out how it changes the equation. So we have a right cylinder, and specifically they're asking us about lateral area. So look for your picture of a cylinder on your formula sheet, and then find your lateral area equation. Well, that's LA equals 2 pi r h. And so what they're telling us to change is the height of the right cylinder is multiplied by 4, and we don't do anything else. So that means we're taking one thing on the right-hand side and we're multiplying it by 4. So if I multiply that one thing by 4 and everything else stays the same, in essence, again, what did I just multiply the right-hand side of the equation by? Yeah, I multiplied the right side by 4. So that means I've got to do the same thing to the left-hand side to make sure that everything's equal. So if I go back, because I don't really have anything else I can simplify. We don't have any other numbers filled in on this one. But the question is, what happens to the lateral area? So what did we do to the lateral area on the left-hand side? Yeah, we just multiplied it by 4. So multiplied by 4. Again, write the info out that you know. Write it out into the equation that you can look up for that shape and then see where you get. So last example, example 6. A sphere has a surface area of 8 pi centimeters squared and a volume of 32/3 pi centimeters cubed. What happens to each calculation if we double the length of the radius? Alrighty, so this one's actually 2 questions in one. So first thing is, they are asking us about surface area and volume. So I need both of those equations. So again, just look those up on your formula sheet. Your volume, actually, you already have those written out. So let's just use those. I'm still going to go ahead and write them out because, again, I want to see, well, what happens when I have to do this to each side of the equation? So r cubed, and then surface area is 4 pi r squared. Okay, so let's fill in what we know. So a sphere has a surface area of 8 pi centimeters. Okay, it has a volume of 32/3 pi centimeters cubed. What happens to each calculation if you double the length of the radius? So the only thing that we're doubling is radius. So where we have our radius plugged in, I'm just going to say 2r instead of r. So let's see what that looks like in the formula. So for volume, that means we're going to do, instead of r, I'm going to write, come on, 2r, but it already has a cubed in there. Wait a second. So what's going to happen if I have 2r inside the parentheses and a cube raised to the 3 exponent? What am I really having to do to that 2r? Well, I've got to take the whole thing and raise it to the third power. So r times r times r, well, that's no problem. That's still just r cubed. Okay. What about 2 times 2 times 2? Well, 2 times 2 is 4. 4 times 2 is 8. Well, let's copy everything else down and see what we've got. So 32 over 3 pi equals 4/3 pi. Oh, wait a second. Here's what I want you to do. I want you to compare. Here's where we started. There's where we ended. What does the final formula have in it that on the right-hand side that the original didn't have? We have an 8. So if you multiplied by 8 on the right-hand side, what do you have to do to the left-hand side? We got to multiply by an 8 there. So how many times are you really multiplying that volume? Volume times 8. Okay, go ahead, try and pause the video and try it out with the surface area. Same kind of thing, plug in 2r where you see an r and see what you have to simplify. Okay, let's see how you did. So again, I'm going to plug in what I figured out, or what they told me was that instead of the r, I want to use 2r because I'm doubling the length of the radius. But same kind of thing, except surface area, I copied that down wrong. That should actually be a squared, not a cubed. So let's save that. That should be a squared. Alrighty. Okay, so, well, what happens when I square 2r? In other words, 2r times 2r? Well, that turns into 4r squared. Copy everything else down. And again, do your comparison. So compare what you started with on that side of the equation with where we're at now. What extra is in there? Yeah, the 4 is in there extra. So that means we have to balance things out, multiply by a 4 on both sides to make that happen, which really means our surface area, surface area gets multiplied by 4. So again, if you'll notice, I didn't even go through to finish out simplifying. I was really just figuring out, well, what math happens when I just make that one small change in the formula and make sure to balance it out. Let me know if you have any questions, and if not, check out your practice problems next. Talk to you soon.